students, and welcome back to Study Room. So, in the last class, we covered the conventional sources of energy. And what did we learn? What is conventional? Conventional are those sources of energy which have been in use for a long time, which are usually seen to be polluting, not that good for the environment. For example, coal, petroleum. And we learned some of the types of energy, how their electricity is generated. Like we learned about the thermal power plant, we learned about hydroelectricity, we learned about wind energy, and we learned about their advantages and disadvantages. Okay, now we're moving on to the next part, which is non-conventional sources of energy. So I think the term itself is pretty self-explanatory, where conventional is the sources that have been used for a long time. Non-conventional obviously means that the sources which have not been in use for a long time, or which are the newer sources, comparatively newer sources. And why have these sources been introduced as a replacement for the conventional sources of energy? Because we have seen that usually the conventional sources of energy either are very polluting in a direct way, like burning of coal produces a lot of smoke, so it's bad for the environment, or in some other way, like we learned hydroelectricity. For that we need to require to build dams, and we saw that dams means displacing a lot of people. Then the ground on which the water is filled, that ground, the plants there start respiring anaerobically. So all of these problems related to conventional sources of energy got people thinking that okay, we definitely need to find some other sources which can replace these sources of energy. So then came along the non-conventional sources of energy, or which are the newer comparatively sources of energy. Okay, so need for more energy. So did someone think that why do we need so much energy? Like we're talking about conventional sources, non-conventional sources, this source, that source, how is this generated, how is electricity generated here, there, why do we need this much energy? Because we are a growing population. The population of earth increases many folds every single day. If any one of you has ever googled the population of earth or the population explosion between say 100 years earlier and today, it is massive. So obviously, because the people are increasing, more people, so that means that some kind of technology keeps on increasing. Like newer people, they want things to be faster, better, smoother. So with these technological changes, obviously there is more energy required. So this is like a chain that goes on. Population increases, technological advances happen, and then the need for energy just keeps increasing and increasing. So as your PPT says, that with technological progress, our demand for energy is increasing day by day. We need to develop the technology to use the available or known sources of energy more efficiently, and also look for newer sources of energy. Right? So this much is clear to us that the conventional sources of energy are not the way to go. Our future cannot depend on the conventional sources. They are way too overcrowded already, they're being used too much, way too polluting for the environment. So obviously we need to look out for some new sources of energy, right? So there are two ways to do that. Either the existing sources, we think about some innovative or new creative way to use them, or we just find completely new sources of energy. Okay, great. So here we have a video. Okay, so in this video, we're going to see what are the things good about solar power. First, you're going to learn how solar energy is actually generated, or how we take the energy from the sun and convert it into electricity. And then we'll see why actually solar power is a much better source of energy, or is considered one of the best non-conventional sources of energy. Okay, let's watch the video. So you keep reading these facts that are shown here. Okay, so it says that solar power is a renewable source of electricity and heat that is derived from the sun. Obviously, I think the name itself suggests. So I want you to keep looking out for these thick yellow lines that they are showing. Okay, they are actually showing you the source where it is coming from. So if you hadn't noticed, you can just rewind the video. If I rewind it for you here, you can just keep looking at the sun. You will see this thick strip of yellow light that will just circle it. Yeah, that. Okay, so this is how they're showing you the path that we are taking, or how solar power is actually converted into electricity. So keep following those little strips of yellow light, okay, or those little yellow strips. So the next point here says that the sun emits energy in the form of solar radiation. So solar It makes sense. Solar means from the sun, and the sun actually emits solar radiations. That is the form in which the sun emits its energy. Okay, it's not light or anything, it's actually solar radiation. That's what it's called. It is in the form of light, but it's called solar radiation. So there the solar energy is generated. Then the technology like solar cells, also called photovoltaic cells, these are the technology which is used to derive that energy from the sun. Now follow that little yellow strips. Okay, look, it is coming into these solar cells and then it is going through these power lines or those electricity lines that you have seen. Then it's saying that solar cells are made out of semiconductor materials similar to those found in computer chips. So semiconductors are basically somewhere between conductors and insulators. So we saw that conductors are material which let heat and electricity pass through them very easily. Insulators are materials which do not let them pass, almost zero electricity and heat to pass through them. So semiconductor means, semi means somewhat, right? Somewhere in the middle. So semiconductors are those materials which partially let heat and electricity be conducted through them, and they're also found in computer chips. So this is just some information for you. Then it says that when sunlight hits these cells, it knocks the electrons loose from the atom. And then can you see this yellow strip came from that electricity line and then it helped the traffic light to get lit up. So from where did it start? It started from the sun. The sunlight reaches those solar cells. Those solar cells convert the solar energy into electricity. It goes through those transmission line. It comes through those transmission line and comes to these other appliances like the traffic lights or even to our homes, and that's how it's converted to electricity. So it says here that as the electrons flow through these cells, they generate electricity. We've already studied about this. Current, electricity, charges that move or electrons that move, electricity flows in the direction opposite to the flow of electrons. We've done all of that. So when solar energy or the sunlight hits the photovoltaic cell, which is basically, photovoltaic means that it is generating that electricity using photons, which is, photo basically means anything to do with light. So sunlight hits those cells and that sunlight, the energy that the sunlight has, knocks out the electrons from those cells or from the semiconductor materials. Those electrons are the ones that conduct the electricity. Okay, great. So here the next point it says is that these photovoltaic power stations and solar thermal power plants exist on a much larger scale. Okay, and when built at utility scale, both systems can provide large amounts of power to the electric grid. So that's basically talking about what scales it can be done in. It can be done in like a huge scale. It can be done to power a whole like city, a small town, or a big factory, or a mall, or something like that. Or it can be a very small scale also. It can be even at the scale of one single home. You'll see that right now. Next it says that the solar thermal power plants use mirrors instead of solar cells to turn the sun's energy into a concentrated heat source. Now, why mirrors? We've already studied about mirrors. What do mirrors do? You remember concave, convex mirrors? They basically converge. You remember concave mirror converges the sunlight at one particular point. So what would happen? At that particular point, there would be a lot of heat and energy of the sun at that point, and that energy is used by the solar thermal power plants for generation of electricity instead of solar cells. Okay, it says that the heat in these, we're still talking about, look at those strips. It's showing you that steam that is being formed at the top of that tower. So in solar thermal plants, what is happening? You remember when we studied thermal plants in conventional sources of energy, it used coal to burn that water, or coal was used to provide heat to boil the water to produce steam, which was used to turn turbines and generated into electricity. So what have we done here? We have simply replaced the coal, which was the polluting factor or the conventional source of energy, and we have replaced it by solar power. And the solar photovoltaic cells, or in case of the thermal power plants, they use the mirror. So even if those photovoltaic cells or photo cells are not used, even if the mirror is used, it is still solar energy because it's being derived from the sun. Okay, and so the water is boiled. In that, steam is used to turn a turbine, and that generate electricity in large quantities. Okay, so I hope the process is clear to you now. And as I said, that it could be at an individual home level also, or like a building level also, or it could be huge solar power plants also. But whether whatever scale it is solar energy. It is a virtually inexhaustible pollution free source. So do you see the two main problems of conventional sources of energy is being solved here? What did we say? Conventional sources of energy are non-renewable. Coal takes millions and millions and millions of years to get formed. So if we keep using it continuously, it would completely get exhausted, right? But solar energy, I don't think, in case if there is one specific phenomenon in the universe that takes place, the sun cannot stop glowing. The sun will always keep giving its heat and light, right? So we can always harness that energy to generate electricity, and it is pollution free. Sunlight, does it pollute us? Does it cause pollution? Does sunlight cause pollution? Not at all, right? So that is why these sources are required. I've already told you these 2 points, which is a clear advantage of the non-conventional sources of energy over conventional sources like coal, petroleum and natural gas. Okay, so keeping that in mind, let us study about solar energy. So here it says that the sun has been radiating an enormous amount of energy at the present rate for nearly 5 billion years, and it will continue to radiate that energy for about 5 billion years more. So if we tap this energy radiated by the sun, we can use it for various processes. Like I said, solar energy is a very good substitute for the conventional sources of energy. Now it's asking you, which one of these boxes do you think is going to be hotter? This black box or this white box? This is the black box is going to be hotter, because it is a very simple reason. You must have noticed that when it is summers, when you wear light colored clothes, you feel much better, right? Instead of, if you're wearing black, you will feel very sweaty, or you'll feel very like hot, especially hot compared to if you're wearing, say, a color like white or light blue or any light bright color. Why is that? That is because the darker colors like black, they have the ability to trap heat energy inside of them. So that is why they feel hotter. So that is why the same logic is going to be used as your PPT says, that black surfaces absorbs more heat as compared to a white or a reflecting surface. So this black box is going to be more hotter, and that is the logic that we're going to use in a solar cooker. So here, if you can see these walls of the solar cooker, this photo, these walls are actually lined by black paper or some black material. So it says that solar cooker and solar water heaters use this property in their working. Which property? The property of dark or black colors being able to absorb more heat compared to light colors. So it says that some solar cookers achieve a higher temperature by using mirrors to focus the rays. Again, another application of the converging property of mirrors. Uses to converge the rays inside the solar cooker, and thus generating a very high heat which cooks your food very quickly, right? Compared to using, the pipes or the gas cylinders that you use, or whatever pipeline comes to your gas pipeline comes to your house. Instead of that, you use these solar cookers. And it says that solar cookers are covered with a glass plate. Again, why glass? Glass is also, it has a property of trapping in the heat. You must have heard the greenhouse effect. You must have seen a greenhouse, or at least read about a greenhouse. A greenhouse is made up of glass, because what glass does, it lets the heat and light energy come into it. Like if there's a greenhouse with plants, heat and light can come into it, but the glass would not let it escape. So what happens inside that place where the glass is covered from, that inside the place, it actually becomes like an oven. Like its temperature rises to a very high amount. Okay, let's move on. So this is the practical photo of your solar cooker. So this mirror, why is it used for? It is used for converging rays, used for converging sunlight to increase temperature. All, if it's a cooker, it's used for cooking food, so its main purpose would be to achieve a very high heat, right? In this case, we don't need electricity, right? So we're not using solar energy to convert into electricity. Here we are using it to convert into heat. So, oh yeah, you can see here the rays are being reflected by the sun, and inside this we've kept this black cooker. Again, why black? Because it is going to trap the heat and the food is going to cook much quicker. And it is covered by a glass sheet. You might not be able to see it, but inside this, like over this cooker, there is this glass sheet. Again, this glass sheet lets heat go in but does not let heat come out. So again, temperature rises, food cooks much more quickly. Okay, great. Now let's study about solar cells. So solar cells are those cells which are present in that solar panel. You must have seen solar panels somewhere around your house or maybe in your school. They look like these bluish kind of big panels which have these small blue cells. So each small cell of a solar panel is known as a solar cell. So that solar cell does nothing but converts the solar energy into electricity. And how? We learned that because it is made up of semiconductor material. When the sunlight hits that material, it becomes like it loses one electron, so one electron becomes free. So like that, there are like many thousands and thousands of cells in a panel. So all those cells lose an electrons, and those electrons are able to conduct the electricity. So that is how solar energy is converted into electricity. Okay, a typical cell develops a voltage of 0.5 to 1 volt and can produce about 0.7 watts of electricity when exposed to the sun. So that is why, because this voltage is very small, so we use a combination or a very large amount of solar cells for there to be actually some significant amount of electricity generated. Okay, so like this, there are solar panels kept at the roof of people's house, and the solar panels are always kept in a way that they face the sun at the time of around noon. Say sun rises from this side and it sets on this side. The solar panel would not be kept facing here. We don't want the sunlight during the sunset time. The strongest and the most direct heat from the sun comes during noon or during the morning to afternoon shift and around the noon and afternoon time, right? So we keep the solar panel facing in a way that we're able to get maximum light during the time of, like from the time of sunrise before sunset, during that noon afternoon time. Okay, and from here, this is the inverter. So from here, electricity is taken to the meter and that is used to generate or power the entire house or maybe even like a whole building or a colony. Okay, what are the pros of solar cells? Pros obviously means what are the advantages of solar cells. So the advantage is that no moving parts. So you remember that in conventional sources we did wind, we used wind energy, right? In that we had these huge windmills which were continuously rotating. So because they're continuously rotating, there might be some friction that develops over time between the axis of those wings and the wings, right? So it might get deteriorated, or the quality of the material might get deteriorated over time, right? But in solar cells, there is nothing that has to like move. It's in one place, it just takes the energy and gives out electricity. So there are no moving parts, so it requires very little maintenance. Okay, so it's less chances of getting like ruined or its quality decreasing over a period of time. And the second pros is, or the second advantage is, they can be set up in remote and inaccessible hamlets or even sparsely inhabited areas. Now, what does remote mean? Remote means a faraway place. Inaccessible means even if we can't go there very easily or there are not many people living there. But if the sunlight received by that place is really high and really good, we can just set up solar panels there, and we can just have these transmission lines which bring the electricity from those faraway places to our city, right? Or they can even use that to light up the villages near that sparsely populated area or that remote area also. Okay, so those are the two pros or advantages of solar cells. Now, what are the cons? You can naturally see that there are little more cons than pros. So what are cons? Cons are disadvantages. So it says that laying of a power transmission line in remote places might be expensive and not commercially viable. Why expensive? Because there are no set transport routes to go there, because it is a very far away, remote, inaccessible area. Not a lot of people go there, so you won't have like your metro lines, you won't probably have a proper road built, you might just have kacha roads, so it might be very difficult to actually get there, and thus it would not be commercially viable. That means even though you're setting it up at a far place, so you're thinking okay, you'll get a lot of electricity, but that setting up process itself takes so much money that it is not actually intelligent, or it is not a wise choice. Okay. The second point says that the availability of the special grade silicon for making solar cells is limited. So there is some special grade silicon, or there is a special quality or type of silicon which is required in making those solar cells, which is very expensive and very sparsely available. It is not easily available, which again makes it difficult for us to set up solar panels. The third point says that the entire process of manufacturing, what does manufacturing means? Making the solar cells, then from the solar cells making the solar panel, then transmission of this electricity to different places. This whole process or this manufacturing is very expensive. And silver, again, silver, what is silver? It is a precious metal, right? Silver has to be used to connect these cells. So just think about it. One solar panel has hundreds and thousands of cells. Now if silver has to be silver has to be used to connect all of these cells, think about how much silver we would need, right? So again, the cost of production or the cost of generating electricity through solar panels becomes super high. And you remember when we were talking about a good energy source, what did we talk about? The most important thing was it should be economical. And economical means that it should not be overly expensive. So we can see that the solar panel setting up is actually a very expensive process, and it adds to the cost. Okay, great. Let's move on. The applications of solar cells. So if you can just see here, artificial satellites, wireless transmissions, traffic signals, all of these, especially satellites, these are not normal usage for people like you and me, right? These are used by ISRO or NASA or these huge research research organizations, because they can invest that much money in making these solar cells, and it is also useful, right? So usually it's seen, even though at today's date solar panels are being made a lot, but this was probably written a little while back. So at that time it was not as easy to make those solar panels for everyday usage or for like people living in normal cities. Okay, so at that time it was mostly used by artificial satellite, it still is, and space probes like Mars orbiters, they use solar cells as their main source of energy. So here it's not written like domestic usage or the usage for people's homes is not written here, because that is not the most common usage, right? So these are the most common applications of solar cells that are written. Then radio or wireless transmissions, or the TV signals or TV relay stations. So like radio or wireless transmissions or TV relay stations in remote locations, they use solar cells. Then traffic signals, there are some solar calculators. If someone has seen, it's actually very interesting to see a solar calculator. You keep it in the sun to recharge it. It doesn't have the normal batteries that your calculators do. These and many toys are also fitted with solar cells, right? So using few solar cells for a calculator or toys is still a economical process than actually making these huge solar panels, because we have to use silver to connect the cells. Okay, great. Now tidal energy. So what are tides? Have you heard of, oh, today it's high tide or today it is a low tide? So what are these tides basically? These tides are nothing but it is a phenomenon which is caused due to the gravitational pull of the moon. Okay. So because of the gravitational pull, this high tide and low tide phenomenon is observed. So as it says here, due to the gravitational pull of mainly the moon on the spinning earth, the level of water in the sea rises and falls, which causes these high tides and low tides. The difference in sea level gives rise to tidal energy. Okay, and this is how this tidal energy is generated. That these are the sluice gates through which the water actually comes into the ocean. This is the barrage, this is the tidal basin, and this is the turbine that is used. So what happens? This water, so you must have noticed by now that a lot of these use actually the turbine, which is rotated, which generates electricity. So when the water goes through these sluice gates, so these sluice gates can be brought down here, right? So if they're brought down here, the water cannot pass through it. But when it's high tide, this sluice gates are taken up or they are released, and this water can easily flow into the turbine. So when this water flows into the turbine with a lot of force, the turbine is rotated and again electricity is generated. Okay, these are all things that make just logical sense to you. So just go through it from your PPT and from your NCRT and it would make sense to you. Okay, great. Moving on to wave energy. So you must have seen, if you have been to the beach, you must have seen these huge waves crashing, especially if you go somewhere like South India. Those waves are just coming at you like they're just going to take you with them into the ocean, right? These are actually waves which have a lot of force and energy with them. They're coming with a lot of force at you. So that energy of those waves hitting the shore can also be used in form of electricity, or that can also be used to generate electricity. Like in high tide, low tide, we used the rise and fall of the water as a source of energy, because those sluice gates open, the water goes through the sluice gates, through the turbine rotates and it generates electricity. In case of the waves, because they are moving and they have a lot of energy while moving, that energy is known as kinetic energy, right? Potential energy is due to position and a height when something is at one place. But when something is in motion, that energy uses, or that energy which is possesses, is known as kinetic energy. So the kinetic energy of the huge waves close to the seashore can be trapped in a similar manner to tidal energy or tidal energy generation to generate electricity, right? So this is the setup that is used. This heavy plate is used to hold the thing in place. This is the cable to the shore, and that this yellow thing or something like a turbine, this is what is actually used to generate the or convert the energy to the electricity, and we get the electricity in the form of this yellow piece. This is actually what is converting the wave energy to electricity. So here also what you have to know is all that the wave energy or the kinetic energy of the waves is used to generate electricity. Okay, great. Now, ocean thermal energy. You must have noticed that in the ocean, the lower layers are at a much lower temperature than the upper layers. Why is that? Because the uppermost layer is completely exposed to sunlight, right? It is completely and continuously being heated by the sunlight. It is directly exposed to sunlight, so obviously it would become hot, the uppermost layer of the water. But as you go deeper and deeper into the ocean or deeper and deeper into the sea, those deeper layers, can sunlight penetrate through the water to get to those layers? No, right? So this difference in the temperature of the uppermost layer of the water or the surface of the water and the deeper layers is used to generate ocean thermal. This is the ocean thermal energy which is used to generate electricity. So let's read in your PPT. It says that the difference in temperature between the surface, like I said, the surface is exposed to sunlight, and the depth of the ocean, which means when you go a little deeper into the ocean, is exploited to obtain energy in ocean thermal energy conversion plants, right? So the energy source here is ocean thermal energy. These plants can operate if the temperature difference between the water and the surface at depths up to 2 kilometers is at least 20 degrees Celsius or more. That means if this is the surface, this is the sun is continuously heating the surface of the water, right? But the sunlight and the sun energy cannot penetrate to very deep layers of the ocean, right? It can only heat up the surface parts of it. So if we go nearer to the bed of the ocean, or much deeper, much more than 2 kilometers, say like 15 kilometers deep from the surface of the water, and say the temperature of the water here is 34 degrees Celsius, and the temperature here is around 70. Sorry, the temperature around here is 34 degrees Celsius, and this obviously is much lesser. So say this is around 10 degrees Celsius, right? So what it says is the gap between the surface and the inner layer should be more than 2 kilometers. So here in this example, we've taken 15 kilometers. So that works. And the temperature difference should be more than 20 degrees Celsius or more than 20 Kelvin. That means if this is a 10 degrees Celsius, 10 plus 20, what is 10 plus 20? It is 30. So this is 34. So it is more than 20 degrees Celsius. So we can actually harness the ocean thermal energy from this kind of a setup. But say if this was not at 10 degrees Celsius, if even at a depth of 15 kilometers, this was just 30 degrees Celsius, only 4 degrees less. Is this enough of a temperature difference for generation of ocean thermal energy? No, right? This is not. We need a much bigger difference. So we would go even deeper into the ocean. We'll go around 50 kilometers deep into the ocean. Then we will probably get a good temperature difference. Okay. So students, this is it for this small part of non-conventional sources of energy part 1. In the next video, we're going to study about the part 2 and some more non-conventional sources of energy. Okay.